Hi there, I'm Vishal, a developer relations engineer at Harness, and welcome to this feature demo where I'll be showcasing the Canary deployment strategy for AWS Lambda. Canary deployment are a vital part of continuous delivery, enabling us to gradually roll out new features of our application while minimizing risks. In this demo, we'll explore how Harness simplifies the process of AWS Lambda function deployment. Before we jump in, let's understand what is Canary deployment. It's a deployment strategy that gradually shifts traffic from old version of an application to the new version in small increments. This allows us to test the new version with small subset of users before rolling it out fully. Why this is needed? Imagine deploying a new version of your AWS Lambda function that introduces change to your production environment. Without a controlled rollout, you risk a full-scale failure if a new version has bugs or issues. With Canary deployment, you can mitigate these risks by first rolling out the update to a small portion of users, giving you a chance to monitor and verify the stability of the new version before you deploy it fully. It also helps with rollback. If something goes wrong with the new version, you can quickly shift traffic back to the previous version without affecting all the users. Let's have a look at the pipeline and understand how it works. I have a simple pipeline that deploys a Lambda function using the Canary deployment strategy. In the service, I have configured a Lambda function definition. In the environment, I have configured an AWS connector that connects to my AWS account, acting as an infrastructure. In the execution, I have used the Canary deployment strategy. By default, 3 steps are added to the process, which we'll go through. The first step is the Lambda Canary Deploy. What this step does is, it fetches the manifest and it creates a new version of the Lambda. The next is the Lambda traffic shift step. We have 2 of these. So what Lambda traffic shifting step does is, it shifts the amount of traffic that we define to the newer version of the application. In this example, I'm first shifting a 10% of traffic to the new version. I have an approval step in between just so that I could go back to my AWS console and verify the stability of the new application. Then I'm doing a 100% shift of the traffic to the new application. Let's run this pipeline and see how this actually works behind the scene. So in the Lambda Canary deploy, we see that the manifest is fetched, and we also store the previous stable version. In case of failure, we could roll back to that version. And we also create a new version of the application. This is the version where the traffic will be routed to. So we have the Lambda traffic shift step that has routed traffic from 0% to 10%. Now you can go back to your AWS console, verify the stability of the new application, and once things seem alright, you can approve or reject based on your analysis. For this example, let me approve this and see how this goes forward. We see that the traffic has been updated from 10% to 100%. Let me rerun this pipeline again and show you how a failure would be handled. we are deploying the function to a new version. So we have shifted traffic to the new version. I'm going ahead and rejecting this just to show how a rollback works. We see a rollback is initiated and the traffic would be shifted back to the previous stable version. We see that the traffic has been shifted and the alias has been updated to the previous stable version. For more information, please check out our official documentation. Thank you.